All right, so recording now. So guys, while we're recording, if you would, please, let's not use any names, but feel free to ask your questions, right? But when you have a question, feel free to ask it. If we do, you happen to use a name, that's not the end of the world. I just have to go back and edit that out of the video so I can post it on YouTube later. I can't have identifiable information of students in the videos. All right. Okay, but seriously, don't let that, if you do have a question, please ask. All right, don't let that slow you down. I want to make sure. I don't want me recording these videos to hinder or negatively impact you guys here in the classroom. All right, so if I need to record these separately, if this becomes a problem, I'll record these at a separate time. But I'm happy, if you guys are happy to bear with me, I'm happy to record these as we go, right? That way I don't have to give the lecture twice, but I can if I need to. All right, so when you go into Canvas, you go into modules. So most of you did assignment 1 for me last time. Thank you. If you haven't done assignment 1, please get that to me. There's no due date necessarily on it, but it's, yeah, let's get that in. Now, assignment 2, then, I've posted and published assignment 2. I think you've got all access to it, right? So assignment 2, you can read through here. I'm asking you to do 2 things. One is there's a scan out of a textbook. I've got a handful of graphics textbooks I'm pulling sources from. So there's a scan of a simple question out of a textbook. And then I'm asking you to make a drawing of something you want to make a drawing of, okay? And we're going to talk about line styles today. And then down here, see, there's, and I'm going to start doing this in most of the assignments. There's going to be what I call supportive readings. And so I've got about 3 or 4 textbooks that I'm just going to scan some material out of, make some pages available to you. Feel free to go through and read it. We're going to talk about the alphabet of lines today, right? And so we'll talk about some of the different line types we will see on engineering drawings, but there's some additional information here. Okay? So again, what you'll find, part of college is learning how you learn, right? How do you learn? Well, repetition helps. Some people can see something once and they get it, especially if it's something they've seen before, have some familiarity with. But most of the time, learning comes from familiarity, and some of that's repetition. So if I do something multiple times, my brain says, oh, that's important, and start remembering. So if I talk about the different line types today in class, and then if you get a chance, you go read these pages out of the text about types of lines, and then you do a couple of problems I've asked you up here, right? Using different types of lines, then send me a PDF of your drawings. Then that's 2 or 3 ways your brain has had to process that information, okay? All right, so that's, again, assignment 2 is here. Let's talk about the theory you need to do assignment 2 today. So I'm gonna stop sharing. Let's go to the document cam here. Perfect. All right, I'm going to do my best to put this in large enough where you guys can see it. I've got old scratch paper here I'm going to reuse. Get as much out of that screen as I can get. Okay. And me being left-handed doesn't necessarily help me here, but that's okay. All right, let's get focus. Perfect. Oh, it needs something to focus on, doesn't it? That's better. Okay. All right, then want to focus on white paper. All right, so we're going to talk about line types today. Okay, so as we've discussed before, we're going to learn a little bit about hand drawing, some basic techniques about hand drawing. So when we actually do things in SolidWorks and it generates the drawings for us, we have some understanding of what the heck it's doing and how simple but yet powerful that is. So grab my notes here. So line types, these are according to ASME standards, there are two line thicknesses. There's a lot in that sentence to unpack there. Let's unpack some of it, okay? Who can tell me what a standard would be? Any guesses what a standard would be?
Understanding of something.
Yeah, that's a good description. Anybody want to add to that? Anything else? Can anybody give me an example of a standard? Or again, you want a further description there?
Agreed upon amount of quantity.
Yes, that's in what you've given there. So an agreed upon amount of quantity. That's a nice definition of a unit, a standard, right? A meter is an agreed upon quantity. The rest of the world has agreed this is what we're going to measure length in, and Americans are at least aware of it. We don't use it, but we know what it is. This is a standardized quantity that we, and for the video here, right, got a meter stick here. This is a standard agreed upon quantity that we use to measure length, right? And oh no, I totally just locked Zoom up trying to switch cameras. Did I? Oh, you're killing me. Okay, so at least this works. All right, so I'm just not gonna, yeah, that's, I think this, it's fine. I'm not gonna chance it. Okay, so on the board behind me, because the webcam doesn't want to switch for me, this is what we talked about in my intro to engineering course today. Some of you guys have had intro with me, some of you guys are taking it right now. We talked about things that slowed or hindered innovation throughout the centuries, and one of those factors is lack of standardized methods. Being able to communicate the same information, being able to communicate is important. Being able to say the same thing and understand what you're saying is even more important, especially for scientists and engineers. So having standards, being able to say the same thing, communicate the same way, crucial, okay? So a standard, a meter, a unit is an example of a standard. A USB plug, perfect example of a standard. The Institute of Electronic and Electrical Engineers, IEEE, sets standards for a lot of electronics. One of those is USB, right? And so beyond just single USB-A, the rectangular plug that goes in the computer here, then you've got USB-B, which is what normally plugs into your printer. That's kind of the more the round one. You got USB-C now that your phone's used to charge, right? Those are all, right? So this is a USB-C plug, right here. There's a standard that says this is the dimensions that plug has to be. Here's how big it is to be able to interface with a phone or any other device that uses USB-C. There's a standard within that standard. It talks about what are the wires in there, what are the pins, what do each of those pins do, what are their limitations, what do they have to be. Here we're going to talk about ASME standards. Can anybody tell me, guess what ASME is?
American Society of Mechanical Engineers.
That's it. ASME is the American Society of Mechanical Engineers. So standards will be agreed upon by some governing body. Sometimes that is a government institution. So the American National Standards Institute, ANSI, that is a standard granting institute. And ANSI will also control these line thicknesses in their standards as well. But sometimes the government will come up with the standards, or a government entity will come up with the standards. Sometimes they recognize standards that are recommended or agreed upon by a society, a professional society like the American Society of Mechanical Engineers, for example, or the Institute of Electronic and Electrical Engineers that determine USB standards. So standards are these agreed upon that we as a society say, this is what makes sense. We'll use these to be reusable. ASME has decided upon a lot of standards for technical drawings. Today, we're going to talk about the line types, the standards of lines. So according to the ASME standards, there are two thicknesses those lines can be, and they are defined as 0.6 millimeters and 0.3 millimeters. So as you're drawing on your paper, keep in mind, I'm going to go back later with my ruler and measure your lines to make sure they are 0.6 millimeters and 0.3 millimeters. And I see some smiles. Some of you realize I'm being sarcastic here. Now, I'm not going to do that. I'm not going to measure your lines to make sure that they are conforming to this standard. But in theory, a good CAD software does. A good CAD software will actually make sure those lines are, there's a difference. Now, here's what I will ask you and what I would suggest to you is make sure lines that are supposed to be thick are thicker than the lines that are supposed to be thin. Again, the goal of this course is not necessarily for you to be artists or even professional technical drafters. That is not my goal. My goal is that you understand how to use a CAD software, and that if you needed to draw something for somebody to communicate to them, that you can. First and foremost, we have to understand there's two thicknesses of lines, right? There's thick lines and there's thin lines. Now there's different types of thick lines and there's different types of thin lines. And that's what we're going to talk about today, okay? All right, so let's talk about, well, and effectively, one thing to notice is that softer, I'm going to put in parentheses here, leads, softer leads can generate thicker lines. So you know how there's the number 2 pencil. The number 2 pencil is a standard on the softness of the, again, in quotations, lead, the graphite in your pencil. It's not lead anymore. I figured that out. Don't do that. We use graphite now. But the softer that material that is actually the writing utensil is, the thicker the line it produces. And you can also affect it by the sharpness of your device too, right? But the number 2, and I don't remember the standard as to what line type it generates normally, but the number 2 pencil generates a certain thickness with a certain stroke of a certain sharpness. And again, that's beyond what I'm asking you guys to be able to do. Just I'm telling you, if it's a thick line type, make sure you make it thicker than something that's supposed to be a thin line type. When you look at a drawing, you should be able to tell the difference between your thick line types and your thin line types. And if you'll do that, then it's going to help both of us, right? But just to mention here, right, softer leads. So we could go to a drafting store, which I doubt they exist anymore, but we go to an online vendor and buy leads of different specification, different standard to generate different thicknesses. And if we were drawing for a living, we might do that. We're not. We're not doing that. So just your standard number 2 mechanical pencil will more than suffice for what we're doing in here. Okay. All right. So let's talk about a few line types. The visible line. It's a nice place to start. The visible line represents features and edges that can be seen in the current view. Now in the next lecture, we'll talk a little bit about different views and representing 2- and 3-dimensional objects. But for now, I think for the most part, we can kind of get some feeling for that. These are things that we can see looking right at an object. These are solid, and they are what I'm going to refer to as thick. According to ASME standards, that should nominally be 0.6 millimeters, but again, we're not going to measure them. We're just going to make sure they're thicker than things that are supposed to be thin. And they're just simply a solid, thick line. Now, the simplest way to generate it, if I'm on the whiteboard, right? So if I'm just, well, let's start here. If I'm just drawing with pen or pencil, you just make at least 2 or 3 passes. Okay, that's the simplest way to make it thick, because you probably, unless you're really good, if you make multiple passes, unless you're really good, you're not going to get the exact same line every single time. You're going to get real close to it, right? And get real, you're going to get real close to it, but you won't just kind of go over the same spot. You will most likely generate something that's thicker than a single pass. Now, again, I mentioned if I'm on a dry erase board, you can see most of these dry erase markers. You see that the edge here, right? How it's not a straight tip, or it's not a rounded tip. And you can get markers that are straight and rounded tip. This is what they call a chisel tip, right? So it's not a straight tip. So you can actually, if I put the entire edge here against the board, you can actually get a thicker line than if I just put the corner of that tip. I can get a thinner line. So you can actually, if you really work at it with a dry erase marker, you can do that. If you're just using a standard ballpoint pen or a pencil, just multiple passes, you can get thick. Okay. Now, from there, if we talk about the hidden line, you can probably guess what this is. It's not real complicated. The hidden line represents features and edges that are not visible in the current view. Next page. Okay. All right, so I'm going to number my pages here. This is graphics. This is going to be, we'll say lecture 1. We'll say this is page 2. All right, so I'm going to go back up here. If I don't do this, I've done enough of these on a document cam, especially during the pandemic, that I know I need to know which page is which, because later I'll have a pile of pages and I'm like, what the heck is, which one is this from? Because I'll need to refer back to something later. All right. The hidden lines are, they are thin lines. And again, that is 0.3 millimeters nominally. Just make sure it's thinner than a thick line. And these are dashed or dotted. So a hidden line, and again, I'm just going to make a single pass. There, it is a repeating short dash. Okay, it's a repeating short dash. Now, the specifications here, well, I was going to show you my notes, but I think I can just get it here. I've not drawn these exactly. I've not drawn the scale. You don't have to, but there is a standard as to how big these dashes are supposed to be. The dashes are supposed to be 1/8 of an inch. And then the gap between the dashes is about 1/4 of that. The gap between dashes is supposed to be about 1/32 of an inch. Do you have to get that exact? No. Just make sure that the dash is longer than the gap between them. It should be roughly about 4 times longer than the gap between them. Make sure it's thinner than a thick line. And just roughly a consistent dash. Okay, and that, for our purposes of rough communication, that will get by just fine. Okay. All right. Another common line type that we'll use a lot of. So these are the 2 line types we'll use the most: the visible line and the hidden line. We'll use these more than just about anything else. The next common line type that we will use will be the center line. The center line. So the center line is a construction line used to indicate the axis of symmetry. It's useful. It's useful in a lot of applications, but it's very useful in cylinders and circles. Okay, very useful in cylinders and circles. But that's not the only application. Sorry, I was thinking something else. And I'm going to quit thinking of other things. I'm actually going to focus on what I'm talking about here. Okay, so the center line. Now, the center line, it is a long dash, short dash. Sorry, I'm off the screen there. It's a long dash, short dash, and then repeat. It is thin. And thin is nominally 0.3 millimeters. Just make sure it's thinner than a thick line. And again, it is a long dash. Now let's see the specifications here. The long dash is supposed to be about 1 inch. The short dash is about 1/8 of an inch, so similar to what we had up here on the hidden line. And the gap between them is a 1/16 of an inch, so about half the distance of the short dash between dashes. So long, short, long, short, long, short, repeat. And again, to give you the specifications here, I'm not going to measure yours. Just make sure the longer dash is longer than the short dash. The long dash is supposed to be about 1 inch long. The short dash is supposed to be 1/8 of an inch long. So make sure your long dash is considerably longer than the short dash. And again, the gap between the two dashes is about half of the short dash, 1/16 of an inch.
Are these things that's programmable, like in SolidWorks?
The standards, are they programmable in SolidWorks? I've not gone in and messed with whether you can adjust them, but they are, almost all CAD programs are going to be done to this standard. Yeah. You can normally kind of define or change or modify line types to an extent, especially if you're drawing things manually, line by line. What happens in SolidWorks a lot of times is we make the part and it generates the drawings for us, as opposed to AutoCAD or something like that, where you have to make the drawings of the part and you have to make the three-dimensional object. You know, we don't, that's silly. That's just, no, because then when one thing changes, you have to change everything. SolidWorks, one thing changes, everything changes with it. And that's modern CAD programs, right? It's not archaic CAD programs. Yes.
Is there an imperial standard for thinking down line in imperial units?
I'm sure we could convert 0.6 millimeters. So let's see, that's and we could run it through a calculator. I don't know it off the top of my head. Yeah, and why do they mix them? I don't know. I'm sure it was probably originally defined in inches and they've just changed it to millimeters over the year and whatever. It's as an engineer in the United States, you get to it, it's just a unit. It's fine. Exactly. So yeah, I assure you, you will get, as an engineer in the United States, you get used to units and units being in different sets, and it's fine. It's not fine, but it is fine. You have to accept that is your reality. It is what it is. Or you go be a scientist, because scientists don't have to deal with the imperial system, right? Unless they work with an engineer. So, all right, what else here? So let's talk about, let's see. we could do a quick example, right, where we use all three of these in something. So if I draw, let's say like a, I don't know, just a cup, if you will. So if I draw a 3D view of some kind of a cup, just a simple cylinder. Right. So just a simple cylinder with an internal cylinder has been cut out to hold liquid or something like that. Okay, just a simple cup. And you could draw your hidden lines in here if you like, but I'm not going to draw a lot of detail here. I'm just going to say, you know, let's just look at a 2D. We're going to talk about 2D versus 3D drawing next time in depth. Today we're basically learning the alphabet today. The lines are like the alphabet, whereas actually making a drawing is like writing a sentence. Okay, so we're basically learning the alphabet today. But if we want to draw just a 2D, let's say maybe a front or side view of this cup, okay, then if I'm looking at this thing like right straight from the front or right straight from the side, I'm not going to see a cylinder. What I'm actually going to see is the outline of that cylinder. That's going to have more of a rectangular view to it. Now, these are visible lines. So I'm going to go back in. You can go back after you, if I'm on the whiteboard, I don't go back and make lines thick until I've done all my lines, and then I go back and thicken them. If I'm doing it by pencil or pen or pencil, you can thicken these as a lefty. If I'm doing them in pencil, I don't thicken them until the very end because I'm just going across it every time. With pen, if I've got a nice drying pen, this is a gel pen, then it's not too big a deal. You can thicken them as you go. Okay, so just kind of all that to say, it's not super critical when you thicken the lines. Just make sure you thicken the visible lines at some point. Okay, so these are all nice thick lines now. And then I can go through and just say, well, you know, there is this internal cylinder removed that we can't see from the side, but I can communicate to the viewer, hey, there is something else going on here you can't see, and this is roughly its shape. Okay. And then I can also say, well, it's symmetric, as you can pretty well tell. But you can say, hey, it is symmetric right down the middle of this thing. It was the same on both sides. And then I could define, like if I need to communicate to somebody and tell them how to build something like this, I could communicate the height, and I could communicate this thickness on one side and the radius. And because I've said it's symmetric, I would only have to define it for one side because the other side has to match because of this center line here. All right, so and a little bit later in the semester, we'll talk about putting dimensions on drawings and defining things. I like for you guys, if we can, to have some experience using SolidWorks before we talk about dimensioning things, because I like for you to actually have some experience having to actually build something in the computer. But we'll get there. Okay? And I'm sure you guys are probably getting tired of me saying, we'll talk about this eventually. And well, we will. We're getting there. We got to go a step at a time. And again, basically today we're learning the alphabet. Okay. So it is a step at a time. All right, so let's talk about a couple of other line types. Again, the pages there that I've scanned for you, they're available in Canvas, talk about a variety of line types. We're not going to talk about all of them. These are the three critical ones, right? We've got to be comfortable with visible lines, hidden lines, and then the center line. And got to be very comfortable with at least visible and hidden lines. Some familiarity with center line. Let's talk about a few line types we'll use from time to time. They're helpful. It's not to say they're not important. They are important. They're helpful. We won't necessarily use them a ton when we're drawing things by hand. The first is a break, and I'm just going to talk about the short break. Okay. So the short break line, there's a long break line, which we could talk about, but I guarantee we're not going to use in this course, so it's beyond us. Occasionally, we might use a short break line, not very often by hand. Most of the time, we'll do it in SolidWorks, but The short break line is a jagged line used. It's a jagged line used to show where an object is broken or cut to show internal features. Right. And we'll see an example of this. I'll make an example of this here pretty soon. To go along with that break line, and by the way, if we draw one, it just has to be a thick line. I like to draw kind of a sawtooth. It doesn't have to be. Again, it's just a freehand line indicating, hey, here's a location where we've created an imaginary opening where you can see, again, this is a thick line. So just make sure it's thicker than your thin lines. And again, it's just we're saying here's the location of an imaginary, could be real or imaginary cut that we've made. So you can actually see inside this thing. You can see some things that are going on. So we won't have to represent everything with hidden lines now, right? To go along with that short break line, when I break something open, I need to indicate to the viewer what is now exposed. And I use what we call section lines. These are used with breaks to show surfaces that are now exposed. These are thin and solid. So it's a thin, solid line. Just a simple, single pass, thin, solid line. They are often at 45 degrees. We draw them at an angle, basically. Okay, so what does that look like? Well, if we take our example from over here, if we take this two-dimensional view of this cup, right? I'm looking at a two-dimensional view of this cup, and if I apply a break to this thing, again, because I can't see from this view the stuff that's going on inside, I can represent it as a hidden line, or if there's a lot going on in there, and I really want to get into it, what I can do is I can generate what's called a section view. And that's where I apply some kind of a break and I maybe zoom in a little bit and I can draw more detail. And so if I have this two-dimensional cup that I had earlier, and again, a cup when viewed in two dimensions from the front or the side, the outline I'm going to see is going to be this rectangle. From this view, I can't tell you what this rectangle represents. We're going to talk next time about using more than one view to represent something in multiple dimensions. But if I'm just looking at the front on view, this is all I see. And again, as earlier, you can draw your hidden lines in here, right? But before I draw the hidden lines, what I'm going to do is I'm going to say, well, let's draw a break down here on the bottom of this thing. Okay. And then what I can do is, whereas earlier, if I had thin lines, or if I had hidden lines, by the way, if you go ahead and dot the whole thing out, it's easier to go back later if you have long lines it's easier to draw them in dotted, especially if you're on a pencil. You'll draw them in dotted first. You can always go in and fill in the dots later. But it's a lot easier to erase if you make a mistake. It's a lot easier to erase dashes than it is a solid thick line. A good solid thick line is really hard to erase, if not impossible, depending on how hard you press. But a dash line like this is your initial rough pass. It's easier to erase that if you make a mistake. Now here in this case, what I've done is I'm saying I'm going to cut away down here below this jagged line, this break line. And now this becomes visible. So I'm saying I'm making an imaginary cut in the bottom corner of this cup. And I've now exposed, this is now where I can see the interior feature inside this cup. Okay, so let's say I cut right in the middle of this cup. I cut the bottom corner off of it. Now, again, what I need to do is I need to indicate which surfaces are now exposed. So what I can do is I can say, well, if I put thin, thin, solid section lines on this surface, because this surface is now exposed, and that tells me which side has actually been cut off. The side that's got the section lines on it, that's actually the side this imaginary cut is there. It could be a real or imaginary cut. We could take a chainsaw and cut this thing open, right? That's fine, but that's not the purpose. Our purpose here is to communicate. Well, if we had made an imaginary cut of everything below this, this is what would now be open. And these are the surfaces that would now be exposed in the section view. Questions there so far? Okay. All right, so again, those are a little more advanced than what we would normally use, but it's perfectly acceptable to use them. Now, there are a couple more line types let's talk about. We'll use these line types, and that's to talk about probably more than the section and the, no, bled through onto that paper. There we go. Probably use the next couple of line types more than we will the section, the break lines. That's okay. Let's talk about dimension and extension lines. So we'll start with the dimension lines. So dimension lines are used to communicate the size or location of an object or feature. And these, so dimension lines are, they're thin, they're solid, and in the current standard, in the modern standard, they have an arrowhead. We'll see those in just a second. To go along with that, with dimension lines, we normally will use, in conjunction with dimension lines, we will use what we call extension lines. These are used to communicate or indicate, or indicate the subject of a dimension. What is being dimensioned, if you will? These are also thin, solid lines. So if we use an example, if we go back to our 2D cup from earlier, or actually we could draw anything. It doesn't have to be a 2D cup, but if I just draw a visible rectangle, And if I just draw a visible rectangle. So again, those are all thick lines, visible lines. My extension lines will point to or indicate what's actually being dimensioned. And I've already used these earlier when we talked about the line types earlier. And then the dimension lines are like this. So let's say that this is, I don't know, we'll say this is 1 inch wide. Okay. And if I go this way, let's say it's 1.5 inches tall. Just thin lines, the dimension lines. The dimension lines are these with the arrowheads. Extension lines, of course, are these guys. Whatever's pointing to, the extension lines point to what is being dimensioned. The dimension lines just indicate between these two extension lines, this is the length being specified. Questions here?
Are the arrows also thin?
Yes. Sometimes I don't always draw them that way, but yes. These are all, should all be thin. Yes, both dimension and extension lines, the entire line will be thin. Yeah. Am I gonna really harp on you too much about these? No. Your visible lines and your hidden lines, you definitely want to make sure there's an obvious difference between those, which one's thick, which one's thin. Dimensions and extensions, it's normally pretty obvious what they are. But in general, try to stick with thin line types there. Other questions? Okay. Let us talk about something else that is good to talk about here. So here I am. Number my pages here. So this is graphics, first lecture. This is page number 3. This is graphics. All right, so one more thing we can talk about is paper size. Types of paper. All right, so in this particular text, you can find a table like this pretty easily. This is Bertolini, 4th edition. Let's focus on that. There we go. All right, so I'm going to put this on the paper here for you, but you can see this is standard, US standard. There's metric. There's an architectural standard. But the standard A size paper is what we call an 8.5 by 11 paper. That's what I'm drawing on here, standard copy paper. Roughly 8.5 by 11, that is 8.5 by 11 inches. That is standard or size A paper, US standard size A paper. So we talk about paper sizes. And so the standards for paper sizes. Size A, of course, is the 8.5 inch by 11 inch paper. Size B paper, so what happens when you go to a larger size, you take the smaller dimension and you double it. So in the case of a size A paper, the small one is the 8.5. So size B has the 8.5 is doubled and the other one stays constant. So it's going to be, we'll pull the 11 over here. It's going to be 11 inches by twice the 8.5. It's going to be 17. And so a size C paper, now the 11 is in the B, the 11 is the smaller one. So in a size C paper, we would double the 11. That's a 17 by 22 inch. Okay. And then of course D, it just goes up from there. The pattern repeats. D would be 22 inch by 34 inch. Now, why would I need something that big? Well, if I'm drawing blueprints for a house, for example, right, trying to fit that house onto an 8.5 by 11 sheet of paper in enough detail to actually be useful gets a little challenging. So what do? Well, I print it out on a larger sheet of paper and I roll that up and put it in a tube, and we take that out on location where we need to. Okay, so we can design things to be bigger. We need a We need a printer, a larger printer to do that. I can draw this. It's a neat graphic to draw here, but I'm gonna go look and see if we can find it on the internet real quick. So let's go share screen. Share. Okay, so if we go, yes. So give me a new tab. Let's go standard paper sizes, and we'll see if Bing will get it for us. If Bing won't get it, we'll go to Google. Images. I have something specific I'm looking. Here we are. So that's kind of what I'm looking for. These are the metric ones. There. This is roughly what we're looking for. So what happens, again, if you take two A's, now this is architectural, but it's the same thing with standard A paper. If I take two A papers, two 8.5 by 11s, and I stack them next to each other, that's the same as a size B paper. If I take two B's, all right, or take two A's and a B and stack those all next to each other, that's the same size as a size C paper. All right, so each one gets doubled. Basically, you take the short side and you double it, and that gives you the next size of paper. And when you nest them, this is what that looks like, kind of visually. That's how that ends up translating. Okay, so again, we could draw that, and I think we ought to, just so you guys have it in your notes. But as I'm trying to draw this crazy drawing, I wanted you to see what I was drawing before we actually drew it. So if I draw basically, and we'll keep this pretty simple, it doesn't have to be to scale. Let's say if I draw an A here and an A there, and you probably should draw it more rectangular than I did. I kind of drew A kind of square, but if I put two A's together, it's basically the same as a B, right? And then two B's together is the same as a C. And then two of these C's together stacks up to be the same as a D. So hopefully you guys kind of get the idea. Okay, so those are standard paper sizes in inches, right? Now, in metric, so the metric standards, the rest of the world, they'll call these out as I always have to look this one up, but it's not something I use on a regular basis. Okay, so you can see here, they use a number. And the numbers, as the page gets bigger, they use a smaller number. So an A4, this 210 by 297 millimeters, that's roughly 8.5 by 11 inches. Close that. So A4 is 210 by 297 millimeters. An A3 then, and it works the same way. You take the shorter side, the 210, that gets double. So it's 297 by 420 millimeters. And you don't necessarily have to remember this. It's just to show you how this works. Okay. Now, the reason I bring this up is when you go into SolidWorks, and we'll have when we actually have SolidWorks make drawings for us, one of the first assignments, it'll say, hey, what size paper do you want the drawing to be on? And the default, it'll probably open up with the metric sizes. So if you see A with a number after it, those are metric sizes. You'll have to actually go dig a little bit to get the US standard, the size A paper. You'll have to go look for it, because it'll start out, it'll give you, all right, now we're not going to write all the numbers out here because you guys see the pattern, right? You just take the short side and you double it. But the A0 paper down here is 841 by 1189 millimeters. That's really big paper. Right? That's a meter. This is almost a meter by more than a meter, right? It's really big paper. But again, when you go into SolidWorks, if you see A with a letter, or sorry, A with a number after it, it's referring to metric size paper. And so The common thing is somebody will grab, oh, I want size A paper. They'll grab the A0 paper, and then it's really, really huge. And when you go to put dimensions on it, and the numbers on this big page the numbers are tiny, and we can fix it. We're just going to go back and change everything and rechange your scale. And it's doable. That's the beauty of SolidWorks, is we can go back after the fact and change almost anything. It's just steps, and that's okay. We can go through that. Okay. All right, questions. Okay. So like I talked about last time, yes, this class meets for a lot of hours. It meets for like the equivalent of a 5-hour class, and that's basically to give you lab time. But on days where I'm going to give you homework, I try to not go the whole time, and that's today. Today's the day I'm going to give you some homework. Go take this home. You're welcome to do it here. But again, I've put assignment 2 in here. Did I put, and I did say, again, assignment 2 has 2 tasks. One is I've scanned a problem I liked out of a textbook. So go do this. That's line types. It's a nice line type exercise. And then task number 2. So the combined is going to be 10 points. Task number 2 is to draw a common household object. Utilize at least 4 of the line types we've talked about today. What have we talked about? 6 today, right? Use at least 4 of the line types. Use all 6, and there's more down here. There's some more line types down here. If you want to use a whole bunch of them. If you've had some drafting before, you want to use any line type that fits ASME standards, fine. Use at least 4. I expect you probably do a visible, hidden, maybe a dimension and a extension line. You're done. All right, that's fine. Pick something out at home over the weekend, or if you want to do it here, that's fine. Use 4 line types. Give me a 2-dimensional view. Answer these questions for me here. All right. Take a scan on your phone. Get you a PDF generator app if you don't already have one. I assume most of you probably have been using one. Get you some JPEGs are okay. If you want to just send me pictures of your work, that's fine. But it's a good skill for you to have to use a PDF scanner, right? And that does the same thing. It takes pictures you've already taken, turns them into a PDF, single PDF file, and you just load one file to Canvas for me. Okay. I'll take JPEGs, try to be organized about it. PDFs are preferred. Questions for me? Makes sense. You can see expected recommended completion date. So this is a whole week. I mean, you should be able to knock this out over the weekend and have this ready by Tuesday. But it's okay. Just don't sleep on it, because you're going to get another assignment on Tuesday, and you'll get another assignment next Thursday. Okay, so don't sleep on it. They're going to pile up if you're not careful. We talked about that. But if something comes up this week and you don't get it done, that's fine. Just get it done the next couple of days. I will try to remind you on Tuesday, but it's on it. You're responsible adults. I'm going to start treating you like responsible adults. I'm happy to do that. Okay, so I'll try to remind you on Tuesday, and then I probably won't remind you after that. Okay, let's knock attendance out real quick. I'm going to stop recording.